Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, my name is Suzanne Miller, and I want to welcome you to the SEI Podcast Series. I'm a principal researcher in the SEI Software Solutions Division. Today, I'm very happy to be joined by Natasha, Shevchenko, and Mary Popeck, who are both engineers in SEI's CERT Division, our sister division. And today, we're going to talk about model-based systems engineering, which is one of my favorite topics. So I'm really happy to have both of you here. Natasha and Mary, welcome to the podcast. All right, so let's start off. Before we get into model-based systems engineering, people like to know a little bit about our speakers and let people know what is it you do at the SEI and sort of what is it that is involved in your day-to-day work. So I'm going to start with Mary, and why don't you let us know?
Okay, well, hi, Susie, and it is a pleasure to be here today. So I came to the SEI to better understand and research and improve the state of software and engineering practices, as well as to assist our customers with enhancing their acquisition and security methodology when they build software-intensive systems and systems of systems. And at the SEI, I've worked with a large variety of customers, such as DHS, the U.S. Air Force, Army, the Intel community, VA, the FDA, and even some commercial entities, such as Roche and Westinghouse. And we go in as an SEI team, we go to our customers and we evaluate their methods, their architecture, and help them better understand their current state, their current practices, and then what are the gaps with any accepted best practices or standards, and how to better mitigate any resulting risks that we find.
Good. And so that has a natural connection to systems engineering, and we'll talk about that in a minute. Natasha, what is it that you do at the SEI?
Thank you, Susan, for hosting this podcast. And it's a pleasure to be here, and I really appreciate the opportunity to talk about model-based system platform. In SEI, I work with different kind of customers to help them to move to using a model-based system engineering, to use digital engineering, to adopt their processes, including agile development process with their engineering practices, help them to start model their system, to understand how modeling affect their work, help them to do better development, to analyze their system, and increase the quality of systems. This is one aspect of my work. Another aspect, since I work in CERT, I work with cybersecurity and threat modeling, and model-based system engineering has a part in this area as well. So we can model the risks on the system architecture, and increase the resiliency of the system using model-based system engineering by actually following the mitigation strategy and analyzes the system consistently. So these two areas come together nicely, and I hope we will be able to address at least some of these topics during this time with you.
Excellent. So you guys make a good partnership. We've got the architect, we've got the modeler. So together you guys can create synergy for our customers in understanding their situations. And that's always the first step to getting better, is to understand where you are. So when we talk about model-based systems engineering, I know some of our audience is new to this topic, and I also know that model-based engineering, model-based systems engineering, and digital engineering are all somewhat related, and you'll hear those terms a lot in the industry and in the government. So why don't we start by having you give us a little bit of what's the difference among those three terms, and why should we care about that difference? Whoever wants to answer that, go ahead.
Let me start a little bit. For example, how model-based system engineering and digital engineering going together. Model-based system engineering is a not very new idea topic. First models regarding engineering happened in the late 40s.
Right.
And it become really popular in the end of 90s, but it's most of the companies that use it, it's big companies with huge security risks and safety risks. They use model-based system engineering as a continuation of their model-based engineering. But with new tools that start to appear in mid-2000s, digital engineers start to play a bigger role, allowing to move these models from a paper-based, documents-based modeling into digital environment, and allow us to make the system analysis repeatable, faster, and do validation and verification of a system on regular basis on a digital representation of our model. And it's actually improves the ability to cope with complexity of the systems that was almost not possible to do on a document base. So we needed, as engineers and system engineers, we need help of tools to do model-based system engineering and analysis. So digital engineering, technically, it's moving your architecture, your models, your model-based architecture into digital environment to use all of its mighty to help you with complexity and necessity to analyze your system regularly and have repeatable processes while you're doing that.
Mary, did you want to make any comments on that?
Yes, I would. So to me, model-based systems engineering is a subset of digital engineering that supports the system engineering activities and functions such as requirements engineering, architecture analysis, design, verification, and validation. So it's the use of a digital model, but it may in fact be multiple models from model-based engineering that are integrated together into one model that allows you to perform the system engineering functions. And by putting them all into one model, it requires more formal methods than what you would do with document-based systems engineering. It adds some rigor and precision, and it also helps communicate with the team much better, because now you've got a way to graphically and mathematically represent the system so that all of the stakeholders have a common system viewpoint.
So if I were to, for our audience, the way I would frame it is, in the past, the models, if you wanted to analyze one or more models, you had a lot of paper to look at. You had many things that, I remember the days of the great big posters, right, that were the printouts on the CAD system of your model. And so anytime you're in that situation, anytime you find something that, wait, that's not right, or wait, we need to change that, or wait, we implemented that differently, we've got a big cycle to go through to actually make changes. And with digital engineering as the home, if you will, for models that are developed using model-based systems engineering techniques, now we've got that dynamic. So now we have a 72-inch television instead of the poster. We still need, a lot of visibility, but we have that ability much easier to change, to talk about what happens if we do this. We can do what-if analysis and things like that were not possible or were not easily feasible in the past. Is that a pretty decent characterization?
Right. For example, if an engineer working in one discipline, maybe thermal or the structure mechanical engineering, wants to add something or change, they have a new requirement they want to implement. Before, with just model-based engineering or document-centric systems engineering, they would make the change and analyze their own domain, their own discipline. But now when you put it into model-based systems engineering and everything's in one model, you can now see the impacts across all the different all the different disciplines within the system, and have a much earlier understanding of what all the impacts are before you actually start building and implementing, and then you don't find out the impacts till much later in test.
So for the example you just gave, if I make a change in thermal, then that could very well imply materials change. I may be going outside the boundary of the heat signature of the materials that I had planned to use. Somebody needs to know that. In the old days, that was the kind of thing that might fall through the cracks, where when we have these models together in the same environment, it's not always guaranteed it'll happen, but it's much more likely that you'll be able to pick up that kind of thing. Excellent.
And you can add the boundaries between hardware and software in parts of a system.
Yeah.
Usually even bigger than between two areas of hardware, for example, material science. They operate almost in silos. So even taking these specific example, the monitoring system that's supposed to monitor the temperature will be affected too.
Yep. So we've been talking about advantages of using model-based systems engineering. That's not where we started, but we ended up there. Mary, do you want to talk about some other things besides, change management that make model-based systems engineering give it an advantage over document-based systems engineering practices?
Yes, I would like to say that when you use document-based systems engineering, humans are managing the documents. They have to keep them updated, keep them consistent, keep them accurate. And we all know that humans aren't as good as computers at doing the detailed, mundane tasks. Humans, we forget things, we skip steps, we're in a hurry, we make mistakes. So this human tendency introduces defects and vulnerabilities and even confusion about what the system really is. So with model-based systems engineering, the record of authority now shifts away from the documents to the digital model. So a human only needs to put their information in once in one place. And this allows model to be quickly updated versus document-based systems engineering. And all the viewpoints for all the stakeholders, they're all consistent. An additional thing is if a modeler makes a mistake when they're putting a change into the model, the application can alert you if you've violated a rule or a framework violation. As well, you can also create tables to help you find those mistakes that are often made. So it's so much easier to find defects, and any defects that are injected, you're going to find them even sooner than you would. You don't have to wait till the test phase to find your defects. Let's see. And I think another big advantage is all your interface problems. You're able to model those early and flush out interface problems. You don't have to wait till you get to integration and testing, where it's so much more costly and time consuming.
Natasha, you had a couple of things I know you wanted to talk about on that score as well.
Yes, I would like to touch the couple of points. One of them is impact analysis and validation, verification of a system in general, and digital environment and modeling environment. You can script it up. It can be done the same way for everybody, regularly, overnight, and make it continuous. And another aspect is we can do simulation on the system even before it was implemented at all. So if your model is mature enough, you can simulate this condition of your system, tweak and change different parameters, see how your system behaves with the different conditions. You can simulate even different architectural alternatives of your system and see how it's work, how it's change under that, and support the different kind of utilities if you have in your requirements for your system. So this actually all of this, what Mary mentioned, and simulations, it's move your architecture and design to the next level. That a lot of mistakes that now and it recently was catched only after development and during the testing can be catched relatively early.
So what you're moving into is sort of talking about how the model-based systems engineering not only improves the product, but actually improves the practices themselves. Mary mentioned, in terms of becoming the record of authority, and giving people a single source of truth as we talk about it. Things like that allow our architects and our engineers to actually spend more time on the analysis and getting it right. And the simulations allow us to do a lot more what-if analysis and things like that. What are some other development practice improvements that you've observed? I'll start again with Mary, in terms of seeing how systems that are composed, especially systems composed of both hardware and software, how it's improved the development practices in that arena.
I would say, kind of expanding on what you already mentioned, that doing system analyses such as performance and timing, those you have to have the entire system to do that. All the hardware and software to do a good job with your performance and timing analyses and trying to figure out how to improve those. So model-based systems engineering helps with that. Where it can also help you is with your quality attributes to a certain degree. If you want to make a change to a feature or a requirement, you can find out across the system, how is this going to impact security? How is it going to impact performance or some of your other quality attributes? You have a lot more insight early on. It also enables you to visualize your requirements allocation and how you're flowing requirements down, or even functional allocation to all the different components. And then you can do trade-offs. Maybe I want to change how I allocated the requirements between hardware and software components. You can play with that, and it also allows you, when you're doing these trades and making decisions, you can capture all of that information in the model. There's plenty of places to put notes and descriptions, so it's all there. It's not just written down on a piece of paper in somebody's desk or safe somewhere. It's now captured in the model that anybody can find in the future if they want to understand why you did certain things.
So the thing that I've noticed in working in some of my customer spaces that use model-based systems engineering is that aspect of I can find notes from other people. That's one that is really, really big in terms of answering the why question, right? Because that as a systems engineer, you ask a lot of whys. And so answering that why question is important. But another one that I've run into is answering the when question, because one of the things I've seen models help with is, when do I need the hardware so that I can have the software integrated with it? And when, what if I change my hardware delivery, which pieces of the software now don't have anything to integrate with and test with? And can I can do some lower fidelity stuff with modeling, but, do I need to add a breadboard in here? So there's some programmatic aspects of this that modeling helps with, as well as the more technical things. And I just wanted to bring that out because a lot of times people think that the model-based systems engineering is just for the really hardcore engineers. But that connection to when do we need things integrated really gives it some more importance in the programmatic space as well. Natasha, did you have anything you wanted to say about that? We didn't talk about this before, but if you've got any comments on that, I'd be interested in hearing them.
Yes, I think especially recently, the implementation of different architectural frameworks using SysML became really popular because it's allow you to do strategic planning in the model early on. So even your your conceptual view of your system, very high level on enterprise level, including organizational structure. You can put in the model and connect to everything downstream, to behavior of a system, to solution of a system before implementation, and then to implementation. So with DODF, UF, TAGF, as a architectural frameworks with enterprise level views in the model environment, allows enterprise architects management to see their view of a system, as well as the engineers and system engineers. And they are right now very eager to see these traceability because most of the time PMOs and management really are interested into required traceability to the solution. They really want to see that none of their requirements fell through the cracks or implemented in wrong place or wrong time, like you said. And model-based system engineering in digital environment actually allow them to do that, to be in control of that, to plan the capabilities on months, and if their work was agile, into BIs ahead, and see exactly how it will transpire to the low level of engineering on the system levels and implementation levels of the systems. And it allows us to do system analysis on that level as well, not only on a lower level, but on a higher level view of a system. So when the architecture ready for implementation, it's developed much better, with more details necessary for a solution to be developed for implementation happened. So this kind of I want to touch one more time of model being as a communication tool between very different levels of engineers, management, and the people who involve in creation of a system, especially large system.
Yep. Well, and we work with some. We work with some very large systems, and so that ability to communicate across a wide swath of stakeholders is something that we have to find ways to do, because we have a lot of them. And I know that one of the things we really didn't mention was that all of this is served by having common access to the tooling environments that allow us to not have to print out a version of the model, to give it to stakeholder X or Y or Z. We want those. That's the other aspect of digital engineering, is making the digital environment accessible to all the people that need to use it. And I'm going to put a plug in for people that haven't thought about it, but until now, learning SysML is not that difficult in comparison to a lot of other modeling languages. And that's one of the most common languages that is used to articulate models. And that is one of the ways that you can become an active stakeholder, in the model-based evaluation and model-based validation. So I'm putting a plug in for people to sort of up their game on learning modeling languages, even if you don't speak any computer languages. Even if you don't write any computer languages, learning SysML is probably not a bad idea. So I'll leave it at that. Security. So you both work in CERT. CERT is the home of computer emergency response team, cybersecurity, engineering, et cetera. What are some particular things that model-based engineering allows you to achieve so that you can get closer to the state that we're all looking for of secure by design? Mary, Natasha, I don't know who wants to take that one.
Mary, go ahead.
Okay. So here at CERT, we work to assist or coach our industry and government customers to help them reduce security weaknesses and make their software-intensive systems more resilient. And MBSE helps with this because you're putting all the information and artifacts, they're all maintained in one place. So there's a single source of truth. And this allows you to reduce and mitigate security risks early in the life cycle. And we all know risk identification and mitigation is most effective when it's done early in the life cycle. So this allows the developers to add in security right at the beginning of the design. They're not tacking it on at the end, and they can try out different security techniques, figure out which one fits best in their system. Otherwise, you've already built the system and you're trying to put something on. That's not as useful.
Okay, and it sounds obvious, but the ability to access both the aspects of the system that have security needs from a quality attribute viewpoint and be able to do that what if analysis inexpensively in comparison to actually implementing something, that is, that continues to be kind of one of the things I hear about in terms of people's desire to do more of this in a model-based systems engineering environment. So want to sort of ask a question that is always something that we ask in our podcast, which is about transition. So model-based systems engineering, yes, I can go to NCOSE, I can learn SysML, but what if I'm new to this area? Are some SEI resources or other resources that are available? How do I learn more about this? Because I've decided that I need to be an active stakeholder now. So where do I go?
If I may touch on this question, I think the number one resource outside of SEI, it would be OMG resources. They have MBSE wiki with a lot of material on that. They have a SysML site, including the certification. If somebody wants to be certified as a modeler or a model user, and even without doing certification, just go through the material they provide for training for certification will give a lot of information as a starter. And I understand that actually it's not a lot of information out there how to start with modeling.
Okay.
It's a few books that tell you how to use SysML, and you can find videos here and there showing specific aspects of modeling using different tools available, modeling environments available right now. And I think it's time for us as the SEI to kind of chip in to give people initial help how to start to think about it. Do we need model-based system engineering in our company? How we do that? Where we start? Right. Who we need to train or not? This is right now pretty much terra incognita. Nobody knows.
So that
very
sounds
much
like
about
that should be in your job jar to start working on some of those things. What are the things that you and Mary and the group working in model-based systems engineering are sort of targeting as near-term research and transition areas in this space?
So I've been building a digital engineering model of a generic federal agency that needs to perform defensive cyberspace operations, DCO. And my coworkers have also been working in this model that I've been building. They're reviewing it, adding elements, changing things based on their knowledge and experience, which is different than mine. So what we're building up this model, we hope to tailor it for each of our customers. If a customer comes to us, says, I'm doing DCO, how do I do it better? Well, we want to take the model and tailor it and model their particular DCO activities. And then help them identify where do they have security gaps. Maybe they didn't implement certain security controls. Maybe they didn't implement them properly. Now we can make recommendations to them, help them improve their security posture and resiliency. We'll be able to help them make recommendations to change their system. And as we use this model with our customers, we will learn more, we will update the model, then the model will become more and more realistic and more useful for our customers.
So that model will go into Natasha's class. But I mean, if we want to educate people, having those kinds of reference models are often critical in helping them to be able to make it real, right? We can put up all the pretty slides we want, but until you actually touch the model, you're not going to see, what is actually feasible. So you've got some things like that. Are there opportunities for people out in our audience to collaborate with you? Should they get in touch with you if they're interested in saying, hey, I'm in a DCO position, I'd like to look at a model like that, or, well, we're not using XML, but we're using XYZ, and, is that something that as part of your research you're looking for as you move forward?
Yes, we are certainly looking for collaboration with people working in this area. And please, if you would contact info@sei.cmu.edu, please include my name and Natasha's name, Mary Popeck and Natasha Shevchenko, in the email that you send, and we will definitely get back to you.
All right. It's always good to have people that are going to help you with those kinds of things, because we always, as you said, humans are not perfect and we always forget things. So I love it when I have people that can help us with what we're moving forward. Natasha, Mary, I want to thank both of you for being here today and talking about this work. This is an area that I also have a passion for and do with a lot of customers. So glad to be able to talk about it. To our listeners, I want to thank you all for joining us today. And we will include links in our transcript to resources we've talked about here, as well as resources that you may want to look at from outside the SEI as well. This podcast is available on the SEI website at sei.cmu.edu/podcast and all the other places you get stuff like that. So thank you for watching, and go forth and model your system. Don't just talk about it. Thanks very much.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.